today we are going to start the new point in the topic electrophilic addition across carbon-carbon double bond and carbon-carbon triple bond. In today's lecture, we are going to discuss the hydrohalogenation reaction in case of the compounds like first is alkene, that is CH2 double bond CH2. The name of this alkene is known as the ethene, and second is the example of a butene, that is 2-butene. That is equal to what formula? That is CH3 CH double bond CH, here CH3. Okay, that is double bond lies in 1 2 3, here 2. Number of carbon atoms is equal to 4 and 1 double bond, therefore 2 butene. Okay, and also along with these compounds we have to start the Markovnikov's rule here. Okay, that is first of all we will discuss here what is meant by hydrohalogenation, then we discuss the mechanism of a Markovnikov's rule when it is applied to the compounds which is a unsaturated one here. So let us start here. That is the point is that first we are going to discuss, that is the definition of a hydrohalogenation. It is defined as the addition of halogen acids. For example, which are the halogen acids? That is HCl, HBr or HI across carbon-carbon double bond is known as what? That is hydrohalogenation. Hydrohalogenation. What is the definition? That is addition of halogen acids towards carbon-carbon double bond. Already we have studied this reaction in a statement in the previous lecture. Now we have to study this reaction in detailed form. For example, we can take the alkene. That is, for example, simple alkene is what? That is ethene, that is containing C double bond C here. Okay. Now addition of a halogen acid such as HBr here, there is formation of the products. Now first point is noted that here the unsaturated alkene and the saturated alkene. Here it is the saturated alkene. Okay, here it is a saturated alkene. Therefore, the addition of a unsaturated reagent towards carbon-carbon double bond, any of this position doesn't affect any of the product. If we add this HBr along this, the bond is closed on this, okay, and Br here close, and this Br is on this. This formation of the product is what? That is CH3 CH2 Br. Okay. Now when this is in reverse position, what is the next product? That is the same product here, that is CH2, here Br, okay, and here CH3. These two compounds are the same. Either here H addition takes place, or either here Br addition takes place. Therefore, in presence of saturated alkene, the action of a unsaturated reagent towards a saturated alkene does not affect the formation of a product. The name of the product is what? That is 1-bromoethane. 1-bromoethane. Now we will consider the another example. First I am going to this example, that is saturated alkene on reaction with a halogen acid. There is formation of a addition product, either this or either this. Okay. Now take the another example like that. First is 2-butene, CH3 CH double bond CH, here CH3. The name of this alkene is what? That is but2-ene. Okay, that is number of double bonds is equal to what? 3. Either on this count, either on this side. Okay. Now addition of this is of a unsaturated reagent. unsaturated reagent. Formation of either, here also two products are same, that is CH3 CH Br CH2 CH3. This is the first product, or plus second product is what, that is CH3 CH2 CH Br, okay, CH3. Okay, now here also number of carbon atoms of the structures of a alkene is also a symmetrical one. Here the name of the compound is what, that is 2-bromo-butane. Okay, and here also what is the name, that is the, here also 1,2-bromo-butane. Okay, on this side here we have to name, that is 3-bromobutane, and here 2-bromobutanes. Okay, now we will consider the unsaturated here alkene. What is the formation of the product here? See the next point, that is the addition of a unsaturated alkene to a unsaturated reagents. What is form here? We are taking the example, that is prop-1-ene or propene, CH3 CH double bond CH2. The name of this alkane is prop-1-ene, which is on addition of a unsaturated here reagent. Okay, this is an alkene, bracket, it is a unsymmetrical one. Now, here the possibility of formation of two products. Which are the two products? Here the products are, first is CH3, here also CH Br, and here CH3, 2-bromo propane. Okay, and here next product is what, that is here CH3 CH2 CH2 Br, 1-bromo propane, 1-bromo propane. Now the question is arises what, that is the addition of a unsaturated reagent towards the carbon-carbon double bond. Here which is the product is the correct one, either one, first one is correct one or second one is correct one. Now this question is arises to 2 hours. Now in order to solve this question, the scientist markownikovs made an empirical rule. Made an empirical rule that is known as Markovnikov's rule. Okay, now the question is that what is the statement of Markovnikov's rule? See here the statement. When an unsymmetrical reagent is added to unsymmetrical alkene, at that point what happens here? First, the negative part of the reagent gets attached to that carbon atom which bears less number of hydrogen atoms. Okay, this is the statement. Or in other words, what I am saying, or the positive part of the reagent, gets attached to that carbon atom which bears what? A more number of H atoms. Here more number of, and here positive part, here negative part, and here less number of hydrogen atoms. Any one of the statement you can take in your consideration may be the same here. Here, what is the statement here? That is when an unsymmetrical reagent. What is the unsymmetrical reagent? That is a HBr. Here positive part is plus H and Br is equal to a negative 1. Here when it is added to an unsymmetrical alkene like a propene, what happens? Negative part of reagent, that is a Br minus, gets attached to that carbon atom that is in the unsymmetrical alkene which bears a less number of a hydrogen atoms, or the positive part of reagent, that is this H, gets attached to that carbon atom in the unsymmetrical alkene, okay, which bears the most number of a H atoms. Okay, now we can apply this rule to the example of a propane as here. Propene, CH3, CH, CH2, Pro 1 ENE plus HBr here, according to what? That is the Markovnikov's rule. What is the positive? This is the plus delta positive plus delta negative. Now this negative part is attached to which carbon atom? Is which have the less number of a hydrogen atoms. This is a unsymmetrical alkene. Unsymmetrical here alkene. Okay. Now this Br is gets attached to that carbon atom and this H is gets attached to here. Now attachment of which here? This bond is gets a broken away. That is, there is formation of a CH3, CH. Here, which part is added? Br, okay, CH3. The name of this compound is 2-bromopropane. 2-bromopropane. Okay, got the answer? In previously, we can write, we have written the two products, okay. Now, which product is the correct one? That is the first product atom. Whatever I am writing, this is the correct one according to the Markovnikov's rule. Now the question is arises, how Markovnikov gets this rule? Markovnikov gets this rule according to its mechanism. Okay. Now what is its mechanism? We have to see here. Next point is the what? That is the mechanism. Before seeing the mechanism, what is this? That is, this is the unsymmetrical reagent. This is a negative part gets attached to a carbon having the less number of hydrogen atoms. Here hydrogen atoms are 3, here 2, here less is equal to what? 1. Therefore, Br is gets attached to here and H is get attached to a this here. Okay, in order to glue the double bond. Now we have to see its mechanism. Okay, see here the mechanism part. Okay, now example is CH3, CH double bond CH2. Now in this mechanism, first step is what? That is the addition of a H plus here. Either of two ways. See here, these are the two ways. Okay, this is the carbon number 1, this is 2 and this is 3. If we attach the unsaturated alkene, unsaturated reagent of this what? Positive part towards either second carbon atom, what happens? And either this is the first way, okay, on second carbon atom, and here on here first carbon atom. Markovnikovs give this mechanism according to the reactive intermediate or reaction mechanism intermediate, that is there is formation of stabilization of a carbocation. Now which carbocation is a very stable or which carbocation is a less stable? In order to we have to just have to test here. If we attach this H, that is the positive species on this unsaturated reagent towards the propene here, propene, what happens here? That is CH3 here, okay. Now this bond is gets glued here, okay. Bonds is glued. Now you have to remember that is one bond contributes how many electrons here? 2 electrons. The bond is glued. That is each of the spaces with the one free electron. That is a free unpaired electron here. That is a free radicals. Okay. Now what happens here? We have to attach the H here. That is CH3 CH, and here also attachment of H2, and here CH2. Now here means a radical. Okay. Therefore this name is what? That is this is a primary carbocation. Primary carbocation. Okay. This is of the electron here remains. Okay. Now second way, on the first carbon atom, that is on this. What happens here? That is here CH3, here CH. Okay. Now after gluing this, that is this is dot here and here CH3. Okay. This is a secondary carbocation. Now according to the reactive intermediates, when this state is formed, that is primary this state, here what happens? Here the pi electron, whatever may be this complex, breaks up and gets stabilized first and then give the products. Okay. As far as this is considered, we have the idea is that is in reactive intermediates we have already seen that it is between this carbocation primary, secondary and tertiary, which carbocation is more stable, that is tertiary carbocation is more stable than the secondary carbocation than the primary carbocation. Now this as far as stability is concerned, what happens here? Which carbocation is more stable? That is this secondary carbocation is the more stable one here. Okay. Therefore, what happens here? According to the here graphical representation, I will show you here. In here, that is energy against progress of reaction. Progress of reaction against energy. The graphical representation is as like this here. Okay, this is of a what? Primary carbocation, and this is of which? A secondary carbocation. Okay, that is this is of this secondary carbocation. This is of what? This primary carbocation. Therefore, which carbocation is more stable? This secondary carbocation. And after getting this secondary carbocation, the nucleophile gets attached on this electrophilic center, and thus there is formation of which state? That is a CH3 CH Br and here CH3. Therefore, this product is the stable one and this product is the correct one according to the statement. Okay. Now, what is the final product here? That is here. Thus, propene CH3 CH double bond CH2 plus HBr gives rise to what? Delta plus, delta negative here. This is gets attached to what? This, okay, and this Br minus gets attached to here. Okay, this bond is close and this bond is gets close. There is formation of CH3 CH Br and CH3. This is the correct one. As far as the stability of this unsaturated reagents is considered, here HI is greater than HBr is greater than HCl is greater than HA. This is the stability of the unsaturated halogen acids. Okay, thus we have here explained the Markovnikov's rules. Along with this, the example of a probe 1 ENE. 1 ENE. In the next lecture, we are going to discuss what? That is the next point, that is known as the anti-Markovnikov's rules, where the addition of a unsaturated alkene does not belongs with a Markovnikov's rule. In the presence of a peroxide, what happens here? Whether the first product is the correct one or the second product, or what the uninspected product. This kind of things we will discuss in next lecture. Okay, I hope that all of you understand this hydrohalogenation concept in very well. Okay, thank you.